So our project, we worked with Georgia Pacific. It's known for their coffee cups. They're the Perfect Touch Dixie To-Go cups that have an insulating layer on the outside. These cups are going to go out of regulation because they contain microplastics. Our goal is to find materials that can also insulate, are compostable within these sustainable standards. To do this, we research fillers that are obviously compostable but also insulating, them to be light. And so the four materials that we came up with to research were perlite, zeolite, rice husk, and cork. To create these samples, we made a slurry using Elmer's glue and the insulating materials. We're just told to keep it simple and just use Elmer's glue. We created an adiabatic design that isolated the heat to only come out of one little window. In that window, we would insert a sample and attach 3 thermocouple probes and pour hot water inside the steel cup, put a temperature probe inside of that, and measure the temperature differential between water on the inside, temperature of the sample. Coming over to our results, we have graphed out the temperature differential of both short-term and our long-term tests. The long-term test was to test how well the samples would keep the heat inside of the cup. Short-term was to see how quickly the sample would heat up. Both tests, there are 2 clear materials that outperformed all the other ones, and that was the perlite and the cork. The cork had the highest performance, but a little bit tougher to work with and also a little bit rougher. Perlite looks and feels the most similar to the industry standard and outperformed polyethylene cups that are on the market. We're going to be shipping off both the cork and the perlite samples to Georgia Pacific so that they can do further testing, and they're super excited about our data and they can't wait to see what all they can do with it. Thank you.